Hello students, welcome back. Today's video is the last video for this unit on waves, and we're going to wrap it up by talking about the thin lens or mirror equation. Okay, so this is the equation that we use to relate the focal length to the distance of the object from the lens or the mirror, and then the distance of the image from the mirror. This is what that equation looks like. This is the equation. It says 1 over f, the focal length, is equal to 1 over do, which is the object distance, plus 1 over di, which is the image distance. Okay, I want to emphasize that this equation can be used for lenses and for mirrors. Okay, I'm going to show you what these variables mean in a picture or an example. The focal length we notate with f, and that is where the light converges through or it diverges away from, depending on what type of lens or mirror. The object distance is, of course, the distance from the object to the lens, and then the image distance is the distance from the lens to the image. If you have 2 out of 3 of the variables, you can find that last variable. And that's what I'm going to show you how to do today. I'll modify this equation to find an equation that we can use to solve for each of those variables. First, we'll solve for the focal length. So if we want to find the focal length, we have to get f by itself. I know 1 over f is equal to 1 over do plus 1 over di. I need to find the inverse of this, which is whenever you flip something. Whenever we take the inverse of something, we take the negative first power of it. Okay, if I take the inverse of both sides, or put both sides to the negative first power, this allows me to flip at least this term. This allows me to isolate f by itself, which is equal to the inverse of all of this added up. 1 over do plus 1 over di. Okay, so if I have the object distance and the image distance, all I have to do is just plug those two numbers into these spots, put it in my calculator with parentheses, just as it is here, and then put a negative 1 exponent at the end. So if my object distance was 3 centimeters and my image distance was 4 centimeters, I would plug in 3 for do and 4 for di. Okay, whenever I put this in my calculator, I get that the focal length in this situation would be approximately 1.7 centimeters. Okay, so I'm going to put a star next to this equation, and we'll save that for whenever we need to find the focal length. Okay, now if I want to solve for do or di, I had to isolate those variables. I'll start off by doing do. So to find do, I would need to get this term off of this side of the equation and move it to the other side. And since it's being added, I'm going to do the opposite of that and subtract it. Okay, so I would subtract it from to this side, and then over here it would cancel out. And I'm going to continue my work down here. Now I have this equation 1 over f minus 1 over di is equal to 1 over do. And just like I did with the last one, I need to take the inverse so that I have do flipped. Instead of 1 over do, I'll have just do. Okay, so I'll take the negative first power of both sides. Whenever I take the negative first power of this term, it just flips it so it says do. Okay, now I have my modified equation so that I can solve for the object distance. I would just do the same thing I did here, but there's a minus sign here. And I would do that the same way in the calculator. I just have a parenthesis, 1 divided by f minus 1 divided by di, close parenthesis, and then put it to the negative first exponent. Okay, I'll put another star by this equation. Okay, so now I need my last equation that has di by itself. And since it's going to be the same exact work I did to find do as I need to do to find di, the equation is going to be exactly the same thing as this, but di and do will swap spots. So my third equation looks like this. Okay, so my image distance is equal to 1 over f minus 1 over do to the negative first power, just like the one we just did. Okay, so these are my 3 equations that I can use to solve for the focal length, object distance, and image distance. So you might want to keep these handy. Before I wrap up this video, I want to talk about the magnification equation, which tells us how big or small the image is in relation to the object. Okay, previously I showed you that magnification is equal to the image height divided by the object height. There's another way you can find this, and that's going to be, and this is also equal to the negative image distance divided by the object distance. Okay, I just want to stress that in this thin lens equation, height is not a factor, but you can use height to solve for magnification. And you can also use the distances to solve for magnification. But to solve for the focal length, you cannot use height, you have to use the distances only in that equation. Okay, that's going to be all for this video. Thank you guys, see you next time. Let us know if you have any questions.